Howdy. AP Calculus Section 1.3C Homework Solutions. This is where we start on page 64, do 39 and 46 through 50. So here is 39. So we've got a perfect cube here. So first of all, you plug in -2 and you're going to get 0 over 0. So we're going to have to do more work on this indeterminate form. So we can factor x cubed plus 8. That's perfect cube. Cube root of x cubed is x. So a is x. B would be 2. So this is going to be x plus 2 times x squared minus 2x plus, if b is 2, 2 squared is 4. Over x plus 2. The x plus 2's cancel out as long as x does not equal -2. So we'll have the limit as x approaches -2 of just x squared minus 2x plus 4. Going to plug in a -2, so we'd have -2 squared minus 2 times -2 plus 4. That's going to be 4 plus 4 plus 4. So be careful with those signs, and the answer is 12. All right, 46. We'll have the limit as x approaches 0 of 1 over x plus 4 minus 1/4 over x. So I'm going to plug in 0. You'll get 0 over 0. So I'm going to do the trick. I'm going to combine these two fractions by multiplying the denominators together to get a common denominator. So that's 4 times x plus 4. Then bring that 4 up here. X plus 4, move it up here. But let's put that whole x plus 4 in parentheses because we have to distribute that negative sign right here across both. It's a common mistake. And I forgot to put the limit as x approaches 0. All right, we'll smush it in there. Okay, so now I can bring this x up a level. And I'm going to go ahead and distribute. That's 4 minus x minus 4. Bring that x up a level, 4x times x plus 4. Okay, so the 4 and the -4 will cancel, and you have the limit as x approaches 0 of -x over 4x times x plus 4. Okay, now this was the whole point of all this work, was to get that x over x there. That's the 0 over 0. So as long as x does not equal 0, we have the limit as x approaches 0 of -1 over 4 times x plus 4. We're no longer indeterminate because there's not a 0 on top, so plug that 0 in there, and the answer is -1 over 4 times 4, which is 16. So -1/16. Beautiful. All right. '47. All right, looks like a similar problem. We got the limit as x approaches almost exactly the same of 1 over 2 plus x minus 1/2 over x. So almost the same as 46. Let's use that quick and dirty technique of multiplying the two denominators. 2 times 2 plus x. Bring the 2 up here, 2. Bring that 2 plus x over here. put that 2 plus x in parentheses so that we can distribute that negative sign over x and multiply this top by 1 over x, and basically that's the same as moving that x up a level. So I have the limit as x approaches 0 of 2 minus x. So I distributed the negative sign across each of those. 2x on times 2 plus x on the bottom. All right, all that's left is negative x on top. And on bottom, we would have 2x times 2 plus x. Just like last time, now we can cancel out the x times x. Remember, you can't cancel out that x. It's attached to that too. But x over x there, you've got the limit. So x approaches 0 of negative 1. And this is as long as x does not equal 0. Every time you cross something out, we have to put this proviso. 2 times 2 plus x. Now we can plug in. We have algebraically manipulated away the indeterminism. That's a mouthful. I almost didn't get that out. So plug a 0 in and you'd have negative 1/4. Algebraically manipulated away the indeterminism. I don't know. Should put that in the description. See if that gets me a lot more views. All right, 48. As x approaches 3, hope I have room to put this in. Root x plus 1 minus 2. All right, looks like we're going to be using the rationalization technique here over x minus 3. Okay, plug in a 3. We've got a 0 over 0. So I'm going to multiply this by the conjugate. Plus 2, so we change the sign right there, over root x plus 1 plus 2. Okay, so that doesn't change this. That's just 1. It's just a fancy version of 1. In fact, I'm going to bring this next one down. So we've got the limit as x approaches 3. All right, let's FOIL this out. Root x plus 1 times root x plus 1 is just x plus 1. Negative 2 times root x plus 1 plus positive 2 times root x plus 1. That whole center section goes away. That was the point. And then negative 2, so we're FOILing here. If you forgot what we're doing, negative 2 times 2 would be minus 4. And on the bottom, I'm just going to multiply them together. X minus 3 times root x plus 1 plus 2. Resist FOILing the denominator for the moment. So that's going to be x minus 3 on top. Look at that. Can you see what happens? It's a miracle. A Christmas miracle. All right, the x minus 3 cancels as long as x does not equal what? What? 3. So now I've got the limit as x approaches 3 of 1 over root x plus 1 plus 2. We have algebraically manipulated away the indeterminism. Now we can plug in. So that's going to be 1 over, plug in a 3, 3 plus 1, that's the square root of 4, which is 2. 2 plus 2, that's a 4th. Seems like last time was negative a 4th. This time is positive a 4th. All right. Better double check and make sure that's the right answer. It is the right answer. Okay. Pause if you need to. Got 2 more to work. These 2 have those pesky delta x's in it. Some students don't like those, but that's not going to be you. You're not going to be afraid. 49. Got the limit as delta x approaches 0 of 2 times x plus delta x minus 2x over delta x. All right, so that's going to be 0 over 0. Let's just multiply that 2, distribute the 2 across the top, see what happens. Sometimes you just got to try some things. So if we distribute the 2, I'm going to have 2x plus 2 delta x minus 2x over delta x. Well, what happens to the 2x and the minus 2x? They go away, and all I've got left is 2 delta x over delta x, because doink, doink. Well, now, as long as delta x does not equal 0, what can I do? The cancel-rooski. So I've just got the limit as delta x approaches 0 of 2. And the limit of a constant is just a constant from the limit laws lecture a few lectures ago. So the answer is 2. All right, last one, limit. As delta x approaches 0 of x plus delta x all squared minus x squared over delta x. Okay, so again, what you want to do is, if we plug in a 0 for delta x, we're going to have 0 over 0. You can do that mentally. Let's FOIL this out. Okay, so I'm going to put that, we're going to x plus delta x times x plus delta x. Because that's just 1x plus delta x all squared, right? Let's FOIL that. See if some stuff cancels. So we'd have, if we FOIL that, it's x squared plus delta x times x plus another delta x times x. That'd be 2x delta x plus delta x all squared. So I'm going to rewrite x plus delta x squared as that. And I'm thinking some cancellation is going to be beneficial. So I've got x squared plus 2x delta x plus delta x all squared minus x squared, we can't forget this minus x squared part, over delta x. Well, what happens to the x squareds? Doinkarooski, doinkarooski. And I've got the limit as delta x approaches bagel of 2x delta x plus delta x all squared over delta x. Now, say, what am I going to do? What could you factor out of the top? That might allow us to cancel something. How about a delta x? So if we factor out a delta x, what's left is 2x plus delta x over delta x. Now I can cancel the delta x's as long as delta x does not equal what? 0. So I've got the limit as delta x approaches 0 of 2x plus delta x. All right, this is no longer indeterminate form. We took care of that when we canceled out the delta x over the delta x. So you plug a 0 into delta x, and all that's left is 2x. So you can take a limit and not just get a number. You can get something in terms of x, which will happen a lot in Chapter 2. So there you go. Beautiful. That does it for this explanation of the homework video. And I will talk to you next lecture.